if you push or pull an object in a particular direction, the object accelerates in that direction. It's simple. This is the second law of Newton. And this is the law that keep in movement all the objects on the environment. What is the formula for work? Work is the force applied in an object during a distance. Is force times distance. And the unit is a Newton meter. Newton per meter. Or Joule. The other name for Newton meter is Joule. This is work. Torque is the force that you apply to twist it a bar. For example, this is the front view of a rod of iron. If you apply a force here, and this is the radius, the torque is equal to the force times the radius. The force times the radius. What is the unit of a torque? It's exactly the same. It's Newton per meter or Joule. Those are the units for torque. The force, 5 newtons, times the distance, 0.4, and this is 2 Newton meters. 2 Newton meters is the torque applied on that object. This is an example in order to calculate the torque. Mr. Newton, in mechanical systems, state that the force is equal the mass times the acceleration. And the power is the work in a period of time. This is power. This is the formula for power in mechanical system, and this is the formula for power in electrical system. Suppose that you have a generator. This is an example. You have a generator of 20 kilowatts. 20 kilowatts. And the engine, this is the engine. The engine is broken. The back end is in perfect conditions, but the engine is broken. And you need to know how much is the horsepower, the minimum horsepower that you need in order to replace that engine for other one in order to supply 20 kilowatts. Okay, you know that 1 horsepower is equivalent to 746 watts. Okay, right now I have 20,000 watts. How much horsepower are? This is the question. Okay, is 20,000 divided by 746. And this is the amount of horsepower that you need to replace the engine. The formula states that the torque should be equal to the horsepower of the engine, times the constant 52, and divided by the engine RPMs. Alright, my friend, this is an important formula. Suppose that we have an engine with a motor of 200 horsepower. 200 horsepower, this is the power of the engine. Okay, we are going to calculate the torque in Y open throttle. Is 200 times 52 and divided by the RPMs in Y open throttle. How much are the maximum RPMs? The maximum RPMs are, for example, 2200. How much is the torque in that point? Is 200 times 5252 and divided by 2200. This is 477.45 Newton meter. Alright, how much is the torque? How much is the torque in idle? The torque in idle is 200 times 52 divided by the RPMs in idle, 900. How much is the torque over there? Is 200 times 52 and divided by 900, and is 1167.11. Alright, what torque is bigger? This one is bigger, the torque in idle. Yes, my friends, less RPMs produce more torque. High RPMs produce less torque. The efficiency is, you talk about efficiency in different ways. You talk about thermal efficiency, you talk about fuel efficiency, you talk about torque efficiency. For example, the fuel efficiency. How can you calculate the fuel efficiency in your car? You have a new car and you have the catalog of the car, and the car said that the fuel consumption of the new car is 28 miles per gallon. Is 28 miles per gallon. Miles per gallon. They say that this is the consumption, and you check, you fill the tank with gas, you drive the tank, and you do the calculation, and you found it that really the consumption of your car is 25 miles per gallon. This is the catalog information, and this is the real situation. It's less. How much is the efficiency in terms of fuel consumption in your car? Okay, the efficiency in my car is the real situation, 25 miles per gallon, divided by the theoretical, 28 miles per gallon, times 100. And this is the efficiency of my car.